What's this question? A paging scheme uses TLB, which means they are saying that there is a TLB concept here. And now access time, a TLB access takes 10 nanoseconds, which means the TLB access time is 10 nanoseconds and the main memory access time is 50 nanoseconds. Then they are asking what is the effective access time in nanoseconds. So they have given the TLB access time and the main memory access time, and they are asking what is the effective access time if TLB hit is 90% and there is no page fault. Okay, what is page fault we shall see later. Now fortunately in this question nothing is given about the page fault, otherwise it would have been much more complex, but it is simple question. It is given in 2008 in IT paper. So now let's solve it. So effective memory access time I already told you. What is the formula for that? Effective memory access time formula is, you need not by heart it as a formula. I mean, if the page is present, I mean, if the TLB contains that entry, then the scenario is only the TLB access time plus memory access time. See, whenever they talk about what is the effective access time or what is the memory access time, they are asking about how much time does it take in order to get a word generated by the CPU. It is not how much time does it take to get a word to get the a page table entry. So whenever they talk about memory access time or effective access time, just remember that they are talking about the CPU. How much time will the CPU take in order to get a word which it wanted. You should not just stop, or you should not just try in order to get try to get the entry from the TLB or the page table. So we are never interested in getting the entry from page table. That is just used in the transformation of virtual address to physical address, which is used to get the actual word required, right? So in this question you just don't write if it the word can be present in the TLB, therefore P into T, plus if it is not present, which means C. Maybe you might think like this. You might think that effective memory access time is, you might think like this: if the word is present in the TLB, then this is the time, and if the word is not present in the TLB, then this is the time. But then this time is fine, but you are trying to say what is the effective time taken in order to get a page table entry, but that is not what they mean. What they wanted is what is the effective time taken in order to get the final word or the final byte from the process, whatever is generated by the CPU, right? In that case, it is not just enough that you get the page table entry, you should even go to the main memory and get the particular word which is generated by the CPU, right? Plus, in case if it is not present, this is if it is present in the TLB. In case if it is not present, then what happens? You have to find out that it is not present, and then you have to go to the main memory and get the page table entry, and then you have to go to the main memory and get the process entry, right? So this is the entire formula. We have already seen it, right? And now what is P? Where is P? Yeah, the hit rate. P is the hit rate, right? P is 90%. So whenever they give in percentages, you better convert it into fractions. What is 90%? 0.9. 0.9 into what is T? T is this TLB access time. So T is 10 plus M is memory access time, which is 50, plus 1 minus this P is 0.1 into T is 10 and then 100. So if you solve it, you are supposed to get 65, this one. So one more thing you have to observe in this question is they didn't mention anywhere about the number of levels used in the paging. So whenever that is the case, always remember that the number of levels might be one level. If it is greater than one level, they'll definitely mention it. If they didn't mention it, it is definitely one level, right? Okay.